welcome to another tutorial. In this tutorial we're going to create a very simple AI using the Finite State Machine class that we've created in one of my other tutorials. We'll also be using Unity's inbuilt AI navigation system to build a Nav Mesh and to define the AI's basic steering behaviors. So the capsule here is our AI and the sphere here is our player, and if our player moves into the capsule's view radius, then it chases them until they leave, at which point it stops chasing them. Okay, so here I am in a new scene. I have this plane that I've created and I've scaled it up by 3 on the X and Z axes. And I've also renamed it as ground because this is going to be our ground layer. We also need to make this static, and that's going to come into play later on when we bake the navigation mesh, which I'll talk about more later on. But right now, so the first thing we want to do, once we have our new scene with our ground plane, is create an object to represent our AI. So in the hierarchy, I'm going to create a new 3D object, and we'll make a capsule. I'll reset its position to the center of the scene, and I'll just increase its Y position to 1, so it sits nicely on top of the ground. Okay, so we can leave the default components on our capsule. In fact, let's rename our capsule right now to enemy. Once we've renamed it, we're going to click on Add Component, and we want to look to add a Nav Mesh Agent. So the Nav Mesh Agent component basically provides a game object with basic steering behaviors. So we can control the speed, how quickly it turns or its angular speed, how quickly it goes from standing still to full speed and vice versa, so its acceleration, and also its stopping distance. So for this, basically, if you want to change the default speed of your AI, you would change this value here. We're going to create different variables to store different speeds for different states of the AI, but the default base speed would be the number that's here initially. But we're also going to change the stopping distance here, and I'm just going to put in 2, and basically that means once the AI gets within 2 units of its destination, it will begin to brake and come to a stop. We can also change how large our Nav Mesh agent is with these obstacle avoidance properties. So radius, if we change that, defines how fat our AI is, so that'll obviously define how large an opening needs to be in terms of width for the AI to move through. And the same thing for height. We can change that to make our AI shorter or taller, which will obviously change how low or high an obstacle has to be for the AI to move underneath it. For this tutorial though, we're just going to leave all the default values for the radius and the height. We're just going to change the stopping distance and, if you like, also the base speed. I should also mention that you need to have auto braking checked on, which basically just means that the agent will start slowing down when it's going to reach a destination on its own. If we have this turned off, that means we can only stop the agent manually by forcing it to through code. So we'll leave this checked on. Okay, so now that we have our Nav Mesh agent set up, we need to create a Nav Mesh. So a Nav Mesh is what the Nav Mesh agent uses to determine where it can and cannot move and sort of figure out where obstacles are. And navigation meshes are static, so they can't move. They're baked over the game world based on the areas that are static as well. So if we select our ground plane, that is why it's important to make sure that the ground plane game object is set to static, which basically means it does not move. So now we need to bake our navigation mesh. So we'll go to the context menu at the top of Unity, go to Window, select AI, and then select Navigation. Okay, so there's 4 tabs at the top of the navigation window. In this case, we're just going to pay attention to bake for now. So here are all our agent settings that the Nav Mesh will use to bake and figure out where it can and cannot move, and how far the boundary from obstacles needs to be. So let's just go ahead and click Bake. So after baking the Nav Mesh, we have this blue area. While we have the navigation window active, we can see the blue area in our game world, this blue area projected over our static objects, that basically represents the area that the Nav Mesh agent will be able to move within. Okay, so I'm just going to quickly add a couple of static cubes around the scene. Okay, so I've added some static cubes around our scene, and I'll rebake the nav mesh now. And we can see that it's carved an area around these cubes out. So basically, the AI will need to move around them and follow the blue area in order to avoid them. Okay, so now that we've created our nav mesh over our environment, and our Nav Mesh Agent will now be able to traverse the environment using it, we'll go back to the inspector window and select our enemy object. I'm then going to go to add component, and I'm going to type in enemy, select new script, and then select create and add. So that's created the enemy script and added it to our enemy object. And now we're going to open the script in Visual Studio. Okay, so inside our enemy script, the first thing we need to do is inherit from a couple of namespaces. So the first one we need to inherit is the Unity Engine AI namespace, which we can inherit by saying using unityengine.ai at the very top of our class, our script. And then underneath that, we need to inherit our Finite State Machine namespace that we created in a previous tutorial. So to do that, we'll say using Finite State Machine. Next, we'll begin declaring some of the required properties in our enemy class. So we'll begin by creating a public float, and we'll call this view radius, and I'm going to give it a default value of 5. So this variable will be used to define the size of the sphere that we're going to generate around the AI that will be used to detect when the player has entered the view of the AI. So after that, we're going to declare a few auto properties. The first one we'll create is our state machine. So this will be a public state machine, and we'll call it state machine as well. And this is of course an auto property. So we want to make this, this to be able to be publicly read. So we'll just say get, but we only want to be able to set the instance of our state machine within this class. So we'll say private set. We'll also assign a default instance of our state machine to our state machine variable by following the auto property values with an equal sign and then saying new state machine, and we'll just use the constructor with no parameters. So the next auto property we're going to declare will also be public, and this is going to be of the type Nav Mesh Agent, and we'll simply call this agent. And just like the previous auto property, this is going to be able to be publicly read, but privately set. Then we'll create one more auto property, which will also be public, and it'll be of the type transform, and we'll call it target, and we'll also make this publicly readable, but only privately settable. Okay, so with our properties defined, the first thing we want to do is inherit our awake function. So in the awake function, we will create the necessary reference to our Nav Mesh Agent. So we want to set our agent property equal to the Nav Mesh Agent attached to the same object as this script. So we use get component, open up a set of chevron brackets, and we want to try and grab the Nav Mesh Agent from this object, followed by some parentheses with no parameters. Okay, so now in the start function, we're just going to write a little comment here, and we're just going to say set state to idle. So when the game starts, we want the object to initially go into its idle state. Okay, so now in the update function, we're going to create the functionality that is going to detect whether the player has come close to the AI or not. So we'll open an if statement first. Now this if statement is going to be responsible for executing the functionality in like 1 in every 10-ish kind of frames, right? So we'll use the random.range method for this. So inside the parentheses for our range method, we define the range from within which to generate a number. So we're going to say any number between and including 0, but up to 10. So up to and not including 10. And we want to check to see if the result of that is less than 1. We could say equal to 0, right? So we'll just say if it's less than 1. So if it is less than 1 or equal to 0, the first thing we need to do is set target equal to null. So we're essentially refreshing our target variable there. The next thing we'll need to do is use overlap sphere to detect the colliders around us, and we'll need to loop through those colliders to check the tags of those objects to see if one is equal to the player. And if it is, then of course we set the value of our target variable to that object. So we'll open a for each loop, and for this one we're going to loop through every collider, which we'll just call col, that we detect in the physics.overlapSphere function. And this will take two parameters, so the origin position of our sphere that we're checking, which is the position of our AI, so we'll just say transform.position to get this object's position, and then the radius of the sphere, right, which is defined within our view radius variable. Okay, so for every collider in this radius, we want to check to see if the tag of our collider, so we'll say col to access this collider that we're currently iterating through, and then .tag to access its tag, and we want to check to see if that's equal to player with a capital P, and if it is, we want to set our target equal to the transform component of the current collider. We can also break the loop at that point. Now there's still one more thing we need to do in the update, which will be outside of this if statement because it needs to execute every frame. So here we want to access our state machine variable, and we want to make sure that it calls its update function every frame. So we'll say on update and end the line. Okay, now outside of our update function, we are going to inherit another monobehavior function, which is called onDraw Gizmos. Now we can use this method to draw visual aids in the scene view, and in this case we're going to draw a sphere to show us the size and position of our view radius, and we're also going to change the color depending on whether we have a target or not. So before we draw the gizmos, and this is called every frame, just like the update. But before we draw the gizmos, we need to set the color essentially. So we'll open an if statement, and we'll check to see if target has a null value. And if it does, we want to set our gizmos to red because there's no target around. So we say gizmos.color is equal to, and then we access the color class and access the red preset. If this does not execute though, so if target is not equal to null, so we'll use an else statement to counter that initial if statement, then we want to set the color to green. So we say gizmos.color, and same thing, we access the color class and then access the green preset. So those statements will set the color of our gizmos, but we still haven't drawn it yet. So underneath that else statement, we're going to say gizmos.drawWireSphere, and this will take two parameters. So we pass the transform.position as the origin position or the center of our sphere, because that's where we want to draw it. And then we say view radius as the second parameter, because that's the size that we're drawing the sphere. Okay, so I'll then minimize the onDraw Gizmos and the update functions. And outside of our enemy class, we are going to need to create a new class, which is going to be an abstract template class for an AI state. So a state that will be used with the Finite State Machine. Okay, so this is going to be a public abstract class. And we'll give this class the name AI State. And of course, for this to function with our Finite State Machine class, this needs to inherit from the iState interface. Now, of course, that'll mean we need to implement the interface. So with our cursor on the definition for the interface, we can quickly implement the required abstractions for the class by pressing Alt-Enter on the keyboard, and from the menu here, selecting Implement Interface, and that quickly generates the required abstractions. So for these methods, we can remove the throw a exception for each of them. And we want to mark these methods as being able to be overridden by any deriving classes. So we can do that by, after the protection level for each method, adding the virtual keyword, which marks them as being able to be overridden. So next we need to think about the properties that we need to define in our abstract class here. So the properties we define here will be accessible by any deriving classes if we choose them to be, if we make them public or protected. So one property that it's likely that all of the AI states will need access to is the actual instance of the AI that's controlling them. So at the very top of the class, we'll create a public auto property, which will be of the type enemy. We'll call this instance. And we want this auto property to be able to be read publicly, but only settable privately. Now, another property that each state might find useful is an ID or a tag kind of thing. So we can define an enum to act as a state ID kind of tag. So above our instance property, we will define our enum by first writing public and then enum. Then we follow that with the name of our enum. So we'll call this state ID. Then we follow that with a set of brackets, and inside here we define the values that this enum can contain. So in this case, we're going to create two states in this tutorial. One will be called idle, and the other one will be called chase. So now that we've defined our enum, we can create variables of that type. So underneath our instance property, we're going to create a public property, which will be of type state ID, and we will call it ID. And just like the previous property, we'll make this publicly readable, but we only want to be able to set the value of this ID within the derived classes from the AI state. So we'll say protected set. Now the last thing we need to create for this template state class is a constructor, so that we can guarantee that our instance property will be set to a reference. So we'll define our constructor underneath our properties. So we'll begin by declaring it as public, and then we need to use the name of the class, which is AI state, and follow that with a set of parentheses and then a set of brackets. So in the parentheses for this constructor, we need to make sure that an instance of our enemy is passed down so that we can make sure that the instance property has a reference. So we'll say that this constructor requires a parameter of type enemy, and we'll call it instance with a lowercase I. And then inside our constructor, we're simply going to say instance with a capital I is equal to our instance with a lowercase I. And that's all we need to do for our AI state template, so we can minimize that class. And underneath it, we'll begin declaring our two states. So we'll declare a public class, and we'll call this AI idle, and this needs to inherit from our AI state class. So to resolve our class definition error here, we'll move our cursor to the AI idle definition, press Alt-Enter, and then select Generate Constructor. So that's generated the constructor required for this class, and we can see that it has our instance variable, and it has this extra section here, which basically means that it's passing the instance variable down to the base definition of the class, which is our AI state, which in that constructor, it takes in the instance variable and sets the instance property equal to it. So we only want to do one thing at this level in the constructor, which is set our ID property. So we'll say ID is equal to eStateID dot idle. Next, we want to override the onEnter function. So we'll say underneath our constructor, we'll say public override, and then we can select our onEnter function to override it. Now we don't want to call the base definition of the method because it has nothing to call. But inside this method, we want to make sure that our AI has stopped. So whenever they enter the idle state, they should stop. So we need to get access to our Nav Mesh Agent. And we can do this through our instance variable. So let's access our instance property. Then through that, we have access to the public variables of our enemy class. So agent is one of those. Now through the Nav Mesh Agent, there's a property called isStopped. And this is the property that we use to manually stop the AI. So if we set that to true, then the AI will be stopped. Okay, next we need to override the onUpdate method. So we'll say public override and then onUpdate. Again, we don't want to run the base definition of the method because there is nothing defined in the original definition for onUpdate. So in this state, in the idle, what we want to do is we want to see if our enemy, the enemy class, has a target. Because if it has a target, then we want to swap into the chase state. So here, we're going to say if instance.target is not equal to null, so if it has a value. Now in here for now, we're just going to put a comment and say set state to chase. Now the last thing we need to do in this class is override the onExit method. And again, we'll remove the calling of the base definition. And here, we're just going to set isStopped to false. So we'll say instance.agent.isStopped is equal to false. This onEnter method will be called when the state is initially entered. OnUpdate will run every frame while the state is active. And then onExit will run right before we transition to a different state. Okay, so for now, let's minimize the idle state. And underneath it, let's begin declaring our chase state. So like our previous class, this will be a public class, which we will call AI chase, and needs to inherit from the AI state class. Just like in the previous class, we will need to implement our constructor in order to resolve the definition error. And in here, we're going to set our ID property equal to eStateID.chase. Now, before we get to redefining the methods for this state, we need to create a couple of variables that will just be specific to this state. So at the top of the class, we will create a public float, and we'll call it speed multiplier, and set that equal to, I'll give it a default value of 2. Now underneath that, I'm going to create a private float and call it original speed and give it a default value of 0. So now underneath our constructor, we can override the onEnter method, get rid of the call to the base definition of the method. Now here in our original speed variable, we want to store whatever the speed of the agent is before we change it to our chasing speed, right? So here we're going to say original speed is equal, and then we need to get access to our instance variable. Through that we can access our agent, and that has a property called speed, which stores the speed the agent is using to move. Now once we've kept track of that value, we can change our agent speed. So we'll say instance.agent.speed on the next line. And we're going to set this equal to whatever our original speed is and multiply it by our speed multiplier. So if our original speed is 1 and our speed multiplier is 2, that's going to set our agent speed to 2. The last thing we'll do is we'll make sure that our agent can actually move. They're capable of chasing the target. So we'll say instance.agent.isStopped is equal to false, so they can move. Next, we'll override the onUpdate method, get rid of the call to the base definition of the method. So here we want to check two things, and if they both return true, then we want to keep chasing the target. So those two things are, we'll open an if statement first. So the first thing we want to check is if we want to make sure we have a target. So we'll say if instance.target is not equal to null. So if it does have a value. Now here we want to check a second condition at the same time. So we'll use two ampersands as the AND operator for C#. Now here we're going to use a static method built into the vector3 class called distance, which will return the distance between two vector3s, but as a float. So we want to check the distance between our instance's position. So we'll say instance.transform.position followed by a comma. And the second parameter we want to pass is our target's position. So we'll say instance.target.position. Then we want to check if that is less than our view radius. So we'll say if that's less than instance.viewRadius, and then we can follow that if statement with a set of brackets. So whatever is inside this if statement will execute under the condition that we have a target and that our target is within our view radius. So in that scenario, what we want to do is continue to move towards our target because we still haven't reached it. So we want to set the destination for our agent. So we'll say instance.agent. Then it has a method called setDestination. And inside the parentheses for this, we want to pass one parameter, which is the vector3, the coordinates for the position we want to move to. So we'll say instance.target.position to make our agent move towards our target, provided that they are on the nav mesh. Now, we need to define the functionality that occurs if we lose our target, or if the distance between our target and our instance position is greater than or equal to the view radius, right? So we'll counter that if statement with an else statement. And inside here, basically we're just going to say transition back into the idle state. So for now, we'll just put a comment and we'll say set state to idle. Now lastly, we want to do one thing with the onExit method. So we'll say public override and then onExit, get rid of the call to the base definition of the method. And here we want to set our agent speed back to its original speed. So we'll say instance.agent.speed is equal to original speed. Right, so now we'll go back up to our enemy class, and underneath our view radius definition, we're going to create a couple of instances of variables for our behavior states. So first, we'll create a public AI idle, and we'll call this idle. And then we'll create a public AI chase, which we'll call chase. So then we'll go to the awake function to construct instances of each state. So first, we'll do our idle state. So we'll say idle is equal to a new AI idle, and in the parentheses we'll pass the this keyword. So we're passing whatever particular instance of enemy is controlling the state. Then on the next line we'll do the same thing for chase. So now we can fill in the comments where we need to set the states. So going down to the start function of our enemy class, what we want to do is get access to our state machine variable, and then access to the set state function and pass in the idle variable as the parameter. So we can minimize that one now and go to our idle state, and we can replace the comment here. And what we're going to do is say instance.stateMachine.setState, and inside the parentheses for the setState function, we're going to pass instance.chase as the parameter. So we can minimize our idle again. And going down to our chase state, we'll replace the setState to idle comment with a similar thing where we say instance.stateMachine.setState, and the parameter for this one will be instance.idle. So with that done, let's save the script, so Control S, and head back into Unity. Okay, so I'm back in Unity now. So we have our enemy with our enemy script attached, and we can control our view radius here. If we decrease and increase the view radius value. But what we need to do now is create an object that's just going to simulate our player. So I'm going to right click in the hierarchy and go to 3D object and create a new sphere. I'll reset its position, move it up on the Y and away from the AI initially. And then I'm just going to change the tag for the sphere that I've created here to player. So let's go into play mode and test our AI. Okay, so our enemy starts in the idle state, and if we move our player close to our AI, the circle turns red, and he gets close and stops, and then when it's beyond the stopping distance, he starts chasing again, and if we go out of the circle, it stops chasing us. But one thing that would be nice to change is if we select the enemy, is if we could change the speed of the chasing state within the enemy script here, just from in the inspector. So let's head back over to Visual Studio. Okay, so above the definition for the chase state, we need to open a set of square brackets, and in here we can define an attribute. So in this case, we want to write system.serializable, and that will make this class visible in the Unity inspector. So this presents a little bit of a design problem. So when we create a new instance of our chase state and assign it to our variable, that is going to override whatever properties we have initially set in the inspector for this variable. So essentially, when we create this new instance and pass the enemy down to that new instance of the AI chase state, we also need to pass the properties that currently exist within the chase state as we've set it in the inspector. If we go back down to our chase state constructor, we just need to add one more parameter here. So after our instance parameter, we'll add a comma, and here we're going to put an AI chase, and we'll just call it chase with a lowercase c. And then underneath here, we're simply going to say speed multiplier is equal to chase dot speed multiplier. So now whenever we construct a new AI chase state, we pass it an existing AI chase state, and it will copy the speed multiplier value from the existing chase state. So now we need to go back up to where we construct our new chase state, and here as the second parameter, we'll just pass chase back into it. So now if we save the script with Control S and head back into Unity, if we select our enemy and come down to our enemy script, we can see this chase drop-down menu, which has a speed multiplier value. And let's say we set this to 3, so we go 3 times faster when we're chasing. Let's hit play. So if I select my player, drag it into the view radius, you can see he gets quite fast. And if I leave, he goes back to normal. So that's all for this tutorial. That's the basics of using Unity's Nav Mesh. Hopefully you found this informative. If you enjoyed this video, please leave a like and a comment, and subscribe if you want to see more game dev tutorials like this. And yeah, thank you for watching.